Okay, so what I want y'all to do first, y'all should know some vocabulary already. So we're looking at word problems for today. I want y'all to go through in each of those little boxes, put in some words that you know that you see in word problems that represent those different symbols. So what are words that are representing your equal sign? What are words that represent your less than sign? Less than or equal to? Greater than? And then greater than or equal to. So go through and fill in, because y'all have done plenty of these word problems before. You should have a few like words that you know when you see it, you know it represents certain things. So give y'all a few minutes to copy or to write them down. Okay, so that's just a quick list. Are there more words in this? Of course. But that's just a few to go off of. These writing inequalities, like that shouldn't be the first time we're doing it. What is new for y'all is writing a system of inequalities, which means it's one word problem that produces two inequalities. There's a little hint that happens for our system of inequalities. It's going to happen a decent amount. A lot of times you look for totals. A lot of our word problems, not every single one, but a lot of our word problems, there's going to be two totals involved, and that's going to help you to figure out how to write the two inequalities. So on this first one, Sue is buying t-shirts and shorts. T-shirts are $14 and shorts are $21. She plans to spend no more than $147 and buy at least 5 items. Show and describe all the combinations of t-shirts and shorts she can buy. All we are going to do is write the inequalities. The only way to solve our inequalities, other than just like plugging in numbers to like guess and check to make sure they work, would be graphing. So the only time that I'm going to specifically ask you to solve an inequality is going to be when there's some sort of graph involved. Unless I'm just asking for a random set of numbers that would potentially work. So in this word problem, what are the two variables? Number of t-shirts and number of shorts. So I'm going to call those. Oh, that was weird. Okay. I'm going to call those X and Y. T-shirts will be X, shorts will be Y. If you wanted to use T and S, that is fine. I don't care what variables you use, as long as you just define them, like tell me what they use. Okay. This problem has two different totals. Do y'all know what the two different totals are? 147 and we're given a total amount of money that she's allowed to be spending. Some sort of thing about money is 147. And we're given a total about the number of clothing items that she's going to be getting. So that's where we're going to generate our two inequalities. One that goes with money and one that goes with just the number of things she buys. So when we're writing it for money, we have to include the prices. How much is a t-shirt? 14. So that would be 14x. How much is a pair of shorts? 21. So 21y. I'm going to skip this blank, or I'm going to skip C because I'm just going to write it down here. And where it repeats A. So combining shirts plus shorts, it says she wants to spend no more than $147.
Wait, that would be one of our words.
Okay.
Less than equal to.
So that would be less than or equal to 147. Wonderful. That was one of our inequalities. We have successfully made one. Now to make the other, we already said it. The second total is coming from just the number of shirts and shorts she wants to buy in general. So when we combine the number of shirts plus the number of shorts, she wants to get at least 5 items.
Oh, that is greater than
or equal to 5. And ta-da, we are done. We're not going to fill in that blank either because it's the same as what we just wrote. We're gonna still do it together. Actually, yeah, go ahead. Do number 2, the one about Angelique and the towels, do that one on your own. See if y'all can do it. After seeing one example, can you do one on your own? What were your 2 variables?
Green and blue.
The different towels, so the number of green towels, and then the number of blue towels. If you wanted to use G and B, that's also fine. Just as long as you tell me whatever you're using. Then there were 2 different totals. This was almost identical to the problem you did. Change out some words, change out some numbers, but pretty similar. There were 2 different totals. One that went with her money amount. She wants to spend no more than $70. So if it's talking about money, you need to include the prices with your variable. So each green towel is $8. So 8x. Blue towels are $10. So plus 10y. Spending no more than $70. What is the inequality for no more than 70? Less than or equal to 70. Good. That was our first system, our first inequality for the system. The second inequality, she wants to get at least 4 towels. So just combining each set of towels. Price is not involved because it's not the total of our price anymore. It's just combining X and Y. At least 4 means what? Greater than or equal to 4. Good. All right. Let's do the one right below it. As we are doing systems, something that you are going to have to make sure you are remembering different words for different math operations. Because this says the sum of 2 numbers is at least 8. What does sum mean? So, adding 2 numbers, they're 2 mystery numbers, so just X and Y, we don't know what the numbers are. At least 8. Greater than or equal to 8. Wonderful. First inequality, done. Second inequality, the sum of one of the numbers and 3 times the second number is no more than 15. So breaking it down, the sum of one number and 3 times the second, how do you write that? Sum of one number plus 3 times the second number. Less than or equal to 15. Good. Less than or equal to 15. No more than 15. Yes.
What number or variable to apply the 3 times?
Because so how I wrote it, I should write it out here. I just called the first number X and the second number Y. But it wouldn't matter. Yeah. This one, it didn't really make a difference because one of them just says add together and the other one just says multiply one of them by 3. If it was a more complicated problem, then yes, that would make a difference. But it's something like that. All right, let's look at the next page. Okay, we're gonna write a little bit, then we're gonna solve a little bit, and then we'll be done going through it together, and you'll have a little bit of practice on your own. So, first part, how do we solve an inequality? Okay, plug in ordered pairs and just see which one works, or graph it. So, our main way to solve an inequality is graphing. Because plugging in an ordered pair gives one of our solutions, which is nice, but solving means giving me all solutions. So to solve something, we need to show the entire shape part. So the only time you are solving this system of inequalities is if I specifically, like if I give you a graph on your paper. That's the only time you're really going to be solving anything. Okay, what part are we solving for? We just said it. When we're graphing, what are we looking for? The solution. Where are the solutions found in the graph? Shaded areas. Shaded areas. But not just the shade, when we have a system, specifically what part of the shaded area?
They overlap.
The overlapping shaded area. And then a little preview. Today we are doing systems of inequalities. Starting tomorrow, we will learn about systems of equations instead of inequalities. So, think about what is the difference between an equation and an inequality.
Equation has one answer and inequality.
Okay. One answer for an equation. Multiple answers. For an inequality. Because of why? What part of like writing or what part of an equation makes it have only one answer?
Equal sign.
Yeah, the equal sign. Inequalities have all of these less than, equal to, greater than, equal to, all that stuff, which creates the multiple answers. Lots of answers. So for a little preview snippet for tomorrow, solving systems of equations, we can graph them. You did that last year.
The more they
But there's more than just graphing to solve equations. Inequalities, all we can do is graph. Equations, a few more options. But that's for tomorrow. We're going to keep with systems of inequalities today. Before y'all do this or try to play games, that has a typo. Don't even like attempt to try and fill something in. It's a typo. This one, we are going to write the system and solve it since there's a picture of a graph here. So what I want y'all to do first, I want y'all to write the systems. We have written a few systems. I want y'all to write the systems based off of this rope problem with John. Go ahead and do that, then we can graph them together. If you feel like you can graph it without me, you're welcome to jump ahead and do that, but we'll do this graphing part together. Make sure your inequality size match mine. Okay. Then getting y by itself. To get this first one to have y by itself, you would subtract x. Are you good with that part? I'm gonna go ahead and graph it since we already have y by itself. Y-intercept is 15, which is an in-between. Then something that is helpful for you guys. The graph is not going by ones, but do they have the same interval? Yeah. So they're both going by twos, which means you can still do the counting process like normal. We can still go down one and right one for the slope of -1. Because it's really going, I mean, you're going down 2 and right 2. Is that the same as 1 over 1? Yeah. 2 over 2 is the same as 1 over 1. That's why that little shortcut can help happen. That little trick, you can still count like normal as long as the intervals are the same. The x and the y axis are going by the same. Solid line because it said greater than or equal to. And then where is the shading going to happen? Above. Wonderful. Okay. Second, inequality, because there's also something with this. Once we get y by itself, we want it to be with the fractions, not with the decimals. So we're going to move the x part over first. It'll be negative on the other side. And then when everything gets divided by that 0.9, negative 0.6 over negative 9 is the same as negative 6 over 9, which simplifies to be negative 2 over 3. Because they both are just one half the decimal. So that means the decimal for simplifying it. It doesn't really matter. And so it's really 6/9, which is 2/3.
So then that would be plus 20.
And then plus 20.
Okay.
If you don't believe me, type 0.6 divided by 0.9 in your calculator. It's going to be 0.6 repeating. 0.6 repeating is the same as 2/3. All right. Inequality is set. Now time to graph it. Y-intercept at 20. We can still go down 2 and write 3 because they're going by the same amount. What type of line are we drawing? Solid. And then where are we shading? Below. Where are all the solutions located? In the green spots. Because, right, art class, yellow and blue make green. Okay. So, what's a possible solution?
Need 26 0.
20. Why are you trying to get? Yes, 26 0 works. 0 16. Yes, those work. If you get to pick one, try not to pick one on the axis because guarantee sometimes you pick it and then you accidentally flip it. What's one that's like for sure just in the green area, not on an axis?
14 6.
And 10. 12. I turn 12 10. Okay. Yes, the ones y'all told me also work. I'm just saying for the sake of like you doing it on your own, if you're trying to give me solutions on a test or a quiz, avoid the axis if you can. Unless you are positive, you are good, you have never messed up on writing an ordered pair for an X or a Y axis ever in your life. If that has never been an issue for you, then great. But I just try and cut down on the chance of having a little mistake. 12 10, we're good. The reason I even like 12 10 is because the ordered pair of 10 12 is also a solution. So heaven forbid you accidentally even flipped it, that one would also be a solution. Wow. Okay, well let's talk about what those mean. What does 10 or what does the 12 10 mean?
Rope A, 12 feet, rope B.
So 12 feet of rope A and 10 feet of rope B. What would the 10 12 ordered pair mean? Flipping it. 10 feet of rope A, 12 feet of rope B. Let's answer this bonus question down below. Could you have just one answer for inequalities?
No.
Not just one.
The top one says 12.
No.
There's not one.
Would it be possible?
Any
No, it wouldn't. You're making this up. I know. I'm like, not think about it. How come?
Because then they have to intersect and that would just.
You have to create that, because of the inequality symbols,
There will always be like a little fraction.
yeah, there's always a little bit that's gonna be,
It'll be like 0.001.
and then we're gonna skip the last problem because we haven't solved all of our system of equations yet. We've done inequalities, just not equations, so I'm gonna skip that last part.